The broadcast is now starting. All attendees are in listen-only mode.
Hello, and welcome to the Aculon webinar, where today we'll be presenting the NanoProof series and discussing waterproofing technology for PCBs. Thank you for joining us today. My name is Edward Hughes. I'm the CEO of Aculon, and I'm joined here with me is Mary Gattuso, who is our Senior Business Development Manager at Aculon and responsible for our electronics business and the NanoProof series in particular. During today's 1-hour webinar, I'll start by giving you an overview of who Aculon is, and then I'll talk a little bit about an announcement we made recently regarding a strategic partnership with Henkel, and give you some flavor for what exactly that's going to involve and some of the roles and responsibilities there. In addition, then we'll talk about why PCB waterproofing is a big deal and there's a high market need for it. Mario then will introduce the NanoProof series of products, talk about some of the application methods, give you a competitive comparison against other alternative technologies that are out there, share with you some independent NPL testing, and then give you some case studies for some examples of NanoProof actions and devices that have been commercialized. And then we'll leave plenty of time for questions and answers. This webinar will be recorded. The recording will be available to all registrants after the program, and we'll be sending out a link for that. In addition, you'll be receiving a link to a copy of the slides of this presentation. And as I say, we are planning on leaving probably 20 minutes of time for Q&A. So please, you'll type in your questions into the question box you see in front of you, and we'll try to address as many as we can as we finish this part of the presentation. So let me start with an overview of Aculon. We are a leading provider of surface modification technologies. We like to think of ourselves as surface solution experts, where we develop and produce technologies to modify a broad variety of surfaces: metal, glass, polymers. Obviously, in a printed circuit board, there are a number of different materials there, and so we produce technologies that are able to protect that against water and other activities. As a company, we produce a number of technology treatments, including hydrophobics, some super hydrophobic, oleophobic, hydrophilic, and adhesion-promoting technologies. All our treatments are very thin. They are easy to apply, and they need minimal amount of equipment. They can be sprayed or dipped or in some cases wiped, and we tend to avoid more capital-intensive batch process type equipment such as vacuum deposition. We have 3 business units at Aculon. The first is electronics, and that's what we'll be focusing on today. We have an oil and gas business and a specialty business. Our business model is that we develop the technology and produce chemistry and ship that to contract manufacturers or to manufacturers for application in their facilities. We are based in San Diego, California. This is our building here. This is where we do our lab and technical development. Obviously, we have a significant amount of IP that goes with this, and you can see our patent wall. And we also do some small-scale production, as you can see on the right-hand side, where we're shipping out pallets of material to customers. We are partnered around the world with representatives in Europe and in many parts of Asia as well. And so as our customers like to have the product close to the marketplace and within a 24-hour to 48-hour logistics window, we have places around the world that can help accommodate that. In North America, Aculon services customers directly. Let me talk a little bit about the partnership with Henkel. Some of you may have seen some of the good media coverage that we received recently. We announced this at the start of October, and it was featured in Paints and Coating Industries magazine, Coating World, as well as various publications in electronics and in Asia and in Europe. So what is this about? Well, firstly, Henkel is going to be a great partner of ours, and we're excited to have them as a partner. They are a major player. They're a German-based chemical and consumer goods company. They operate in a number of different fields, obviously, including electronics. They're a large company at about 22 billion euros last year. And their electronics division is based in Irvine, California, which is about 60 miles up the road from us. And we've been working with Henkel for a while to basically look at this waterproofing technology. Originally, they approached us and said that they're looking for a solution-based waterproof technology to fit in as part of their overall waterproofing strategy. As you may be aware, they are a leader in sealants and gaskets and other applications to help waterproof devices, and this provided a opportunity for them to work with us to deliver some unique solutions to this. So we've entered into a strategic partnership with Henkel, and the primary focus of that partnership is really for large mobile device manufacturers. They're looking for high volume applications. We've already industrialized one particular product with them and working on others. So if you're on this webinar and you are a large mobile device manufacturer, the way this would work is that Aculon would be the technology provider. So we'll be working with Henkel to provide the technology and any customization necessary. But Henkel would handle the commercial aspects of this, including application testing and process support, manufacturing, supply, invoicing, and quality assurance. They would also provide customer technical support for both specifications and products, an on-site product. So if you are a large mobile device customer or unsure whether you'd fit into this, then Mario will be giving his email address at the end of this webinar. Please just email him and he'll put you in touch with the right person at Henkel. If it's somebody that is not going to be covered by the partnership, then we would work with you directly. So a couple of different options there depending on the type of business that you are. So let me switch and talk a bit about PCB waterproofing because it's becoming a big market and it's certainly becoming a big need. And we're seeing lots of devices, whether it's mobile devices such as smartphones or tablets or wearables, basically trying to build in waterproofing as a standard feature. And obviously, there's a couple of different ways to do this, but it's becoming pretty standard that, trying to prevent consumers from damaging their devices by water is a big deal. And we're even seeing this now on desktops and laptops as well as other IoT devices. So this is really a growing need and one that we feel the process flexibility of what we provide in terms of a solution-based treatment is going to be a winner, and it's going to be seeing a lot of market adoption, not just for these types of devices, but also for medical devices. In addition, we are picking up quite a lot of business from customers that have traditionally used conformal coatings, but don't like the hassle of the conformal coatings in terms of the lack of reworkability and, frankly, some of the protection against water. So this market is growing. One particular area that is obviously receiving a lot of focus is the smartphone market. IDC projects about 1.7 billion smartphones will be shipped in 2020 for about $400 billion. But more than 900,000 smartphones a day are damaged by liquid. So clearly a big issue. As you can imagine, if you look at the breakdown of damage to mobile devices, a good chunk of it, nearly 50%, comes from shattered screens, and I'm sure we've all seen or witnessed that. But another, the second biggest area really comes from damage caused by water. And it can be in various forms. It can be dropping it into a pool or to a toilet, or it can be just splashing water onto it and getting into the ports and damaging it. So, about 35% of the overall damage is basically caused by water damage. So it's a big deal, and it's obviously a concern for those device manufacturers, but it's also a concern for other ones. We put together a little fun video that we'll play you for showing you an example of waterproofing. I need you to waterproof my phone. Okay. Brilliant! Brilliant! So as you can see, a kind of a fun video based on obviously an original Guinness ad that we put together for a St. Paddy's Day type promotional video. So obviously consumers are damaging their devices in daily life, whether it's dropping in pools or toilets, or we do quite a lot of work now on outdoor lighting, telecommunications, switching equipment, where you've got the outdoor environment, rain or humidity playing a role there. And then there's obviously a number of applications in industrial settings or medical device settings where they're exposed to kind of wet working conditions, and people are looking for some protection on this device. So when we start to work with customers, we often get people call us up and ask us, can you waterproof our device? And the answer is sure. What kind of waterproofing requirement do you need? And we like to use this scale. It's the IPX scale, and it gives you different levels of waterproof protection. And so this really helps us understand what is that device likely to see and what is the customer looking to protect against. So obviously in some cases, you are worried about splashing water or potentially humidity or condensation. In other cases, such as mobile devices, mobile smartphones, they are looking for full water protection for 30 minutes and beyond. So this helps us understand the level of waterproofing that someone's going to need, and that helps us obviously pick which of our treatments is probably the most appropriate for that and the easiest from a process standpoint to do. And now we've been doing this for a while, we've kind of come up with some recommended level of IPX requirements or protection for the common devices that we've seen. And as you can see, from on the right hand side, you've got level 7, which is 30 minutes immersion at up to 1 meter depth with mobile devices. But many devices will fall into a level 4, whether it's headphones or a printer or automotive type applications where they're worried about splashing water. Those things, or shower types applications, those things are kind of more appropriate. So if you work with us, we'll try to help understand early on what type of waterproofing you need. So it's not just when someone says if the marketing person says I need waterproofing, it's kind of let's really start to define that a little bit here so we can make sure we're testing what is appropriate. So what we've done is we've created a series of different products to basically address a variety of situations, from humidity to full water immersion. And Mario is going to take you through that and talk about some of the options as well as some case studies in that. So Mario, please take it away.
Great. Thank you, Edward, for that excellent introduction. So as Edward mentioned, we're going to talk about the specifics of the NanoProof product line. As mentioned, the NanoProof line offers protection all the way from just basic humidity up to full water immersion for significant lengths of time. All of the NanoProof products utilize proprietary technology and are produced here at Aculon. They surpass competitive conformal and vacuum-applied coatings, both in terms of performance and also ease of use. And their application equipment, because these are liquid-applied coatings, is affordable and readily available. In many cases, it's possible that you already have the application equipment in your facility that these can be utilized in. Some of the key benefits of NanoProof, aside from the very important benefit of waterproofing the parts, is they're going to reduce product returns due to water damage. Improved yields, as rework is still possible after coating. So as I'm sure you know, with traditional conformal coatings or vapor deposition, once that coating is down, if there's a failure on the board, it's very unlikely you're going to be able to rework it. Whereas with NanoProof, it's easily removed and reworked. For application, there's no or minimal masking required. These can be in some cases applied over the entire board, eliminating masking, or in other cases applied in a selective manner very easily, so that areas that cannot be coated are left alone. These coatings are safe and non-toxic and can all be used in the factory environment. We also offer VOC and flammable-free variants as well. And they are all, on a per-unit basis, extremely affordable. So here we have an overview of the NanoProof product line. gets into details on some of the specifics of each. I'm not going to go through every single line. This will be available in the recording and in the slides, which we will email to you after the webinar. But basically just covers from NanoProof 1, which is our base level, extremely easy to apply material. Typically has a thickness around a micron, provides humidity and incidental protection all the way up to the 7 and 8.4 series, which are thicker in the 30 to 40 micron recommended thickness range and can provide up to IPX8 levels of protection and are implemented in several applications already. As you can see here, for your automated inspection needs, every single NanoProof variant comes with a UV inspection die. If for some reason you need a clear coating or do not want a UV dye in the coating, we can also provide you with a UV-free variant. But standard, they do come with a UV fluorescing dye. Another significant benefit is that the thinner variants of NanoProof do not impact the key components. So antennas, headphones, microphones, buttons, cameras, displays in some case can all be coated. Care does need to be taken with the 5, 7, and 8 series as they're thicker, so they can have some undesired consequences if they are coated on some of these parts. But in some cases, they can be coated there. So now we'll get into how do we actually test to confirm the efficacy of these different materials. So from the get-go, we've utilized these IPC test boards. Essentially, they're little multi-purpose test patterns. They can be coated with the different solutions, the different nanoproofs, and then they can be put under voltage and inserted into water or exposed to a variety of conditions. And you can measure current leakage and the levels of corrosion on the board to evaluate how the coating performs. So typically we'll coat the boards and then run them at 60 minutes in water, powered at either 3, 6, 12, or 18 volts, and then measure the current loss and then also evaluate qualitatively the appearance of the board to see if there was any corrosion. So as you can see here, this is an example of a 7.0 test run under 18 volts. This was in water for a significant amount of time. The failure threshold is very, very low. It's at 500 nanoamps, and you can see that on one of the tests there are some spikes up to 200 nanoamps. The other two tests didn't even break. One got up to about 150 nanoamps, and the other didn't even break 100 nanoamps. So these are very, very effective at protecting the board from failure. These boards look perfect after they came out of the water. So it's a very good proxy for testing how effective these coatings are. And in addition, we have developed a paper that goes into far more detail on this testing, and we'll be emailing out links to download it. It's also available on our website. So the traditional IPC test boards do a great job of confirming whether the material will protect from water damage, but they don't always provide a real-world test result. So in the real world, your parts in almost every application have three-dimensional components and edges and features that need to get coated. And so what we were finding is that materials that would pass with flying colors on the IPC test board would then fail in the real world. And so we needed a proxy to determine or to predict how different coatings would be able to protect a board in the real world. So we came up with an additional test in addition to the IPC test board, which was coating these LED strips. They're very basic, simple. They can be powered up. You can observe their function because the light is shining while it's in the water, so you know that whether it's working or not. So essentially what we will do is dip these LED strips and then run them similar to the IPC test board, where we run them under voltage in water for 30 minutes to an hour and then evaluate the components for failures. We'll look for evidence of corrosion, and this is a very good proxy of determining if the coating being evaluated is capable of offering a real-world protection by essentially coating the edges of the components. So now, to get into some of the testing we ran, so a common conformal silicone, which passes the traditional IPC testing with flying colors, fails on the LED strip testing in almost all cases. Even putting down multiple coats, in some areas as thick as 100 microns, the LED strip still failed. And that's because they don't coat the sharp angles. They slump off the board, so you may have 100 microns of coating on top of the resistor or on the sides of the resistor, but those top corner edges are exposed, and you can see in the picture that there is significant corrosion on that top edge. And that silicone does not lead to a real-world IPX7 approach. Same with the acrylics conformal coating. It passes the IPC board testing with flying colors, but then fails on the LED strip. It does not coat the sharp angles and does not lead to real IPX7 levels of performance. So with the materials that we've developed for IPX7 here at Aculon, they not only pass the IPC board testing, but they also pass the LED strip testing because we formulated them specifically for water protection, and they coat the sharp angles of the components. So after process optimization on your part, real-world IPX7 levels of performance are expected. So now to cover some independent testing that was done by a company called, or an organization called NPL out of Europe. They essentially, this is a two-phase test, and this is summarizing their study in phase one. So phase one is comparing the performance of traditional conformal coatings to kind of the new age coatings that NanoProof has developed, which provide edge coverage. They compared directly conformal coatings, the Aculon coatings, and also combining the two coatings together. And essentially what they found in this stage, because the focus was on those IPC test boards that we had previously discussed, is they confirmed that the NanoProof provides protection, they confirmed that the conformal coatings provide protection, and they confirmed that using both also provides protection. So it's as expected, and we have some independent testing showing that the NanoProof material does provide the level of IPC protection that we've discussed or disclosed in our internal testing. So what's most important is their next round of testing, where they're going to start testing on three-dimensional devices, where we would expect to see failures with the traditional conformal coatings, but passing parts with the Aculon coatings. So we're excited to get the results of that testing and to share it with you once it's available. So here's another video kind of showing exactly how what we've done is in the real world. So this phone has been treated with NanoProof, and as you can see, it's after dropping in a fish tank, it is still functional after a half hour. So the next thing you're wondering about, I'm sure, is how do you apply NanoProof? So NanoProof, being a liquid, can be applied in a wide variety of methods, extremely flexible application options. It can be sprayed, dispensed, jetted, dipped, in any other method of applying a liquid to a surface that you can think of. Depending on which NanoProof you're utilizing and also the specifics of your application, some of these application methods may be more desirable. In the case of, say, 7 and 8.4, which are thicker coatings, you're not going to want to spray those coatings, or you're not able to spray them. In the case of, say, 1.0, and you wanted just some minor protection, you want to coat the whole board, then with 1.0, you would certainly want to spray that onto the board, or you could dip it just as easily. The coating equipment for these products is readily available from companies like Nordson, Simtech, and PVA. And now we'll get into a comparison of some of the different waterproofing technologies that are on the market, from gasketing to vacuum deposition to next generation liquids. So gasketing has some very good pros. It has excellent initial performance. IPX5 up to IPX8 levels of performance are expected. The only downsides to gasketing is that it's complicated, it uses up valuable real estate, requires either elimination of ports or some sort of plug in order to still utilize a port and not have water coming in. And as we all know, those plugs oftentimes end up lost or broken. And they're prone to catastrophic failure. If that gasket fails and the part gets immersed in water, then the water is going to get inside the phone or the device and certainly fail. Vacuum deposition is the other option available. It offers lower levels of performance, typically IPX2 to 5. And it's hugely complicated. It requires masking and demasking, very expensive capital equipment. The vacuum chambers where the materials applied are not cheap at all. And it can be a slow process because it's a batch process. It can be a bottleneck in your production line. And now the next generation options, such as NanoProof, offer a variety of performance levels from IPX3 up to IPX7, in some cases IPX8. Very easy to apply, will cover complex features, and are extremely cost effective. The only real downsides is they can be, in some cases, process optimization intensive, and many of them do contain VOCs, but we do have VOC and non-flammable variants if that is a concern, so that's something we can address as well. Here's a summary summarizing the different characteristics of gasketing, CVD, and the NanoProof technologies. Again, to summarize, the gasketing is a very, very well-performing initial option, but the phone can get damaged, and over time it can fail, so it may not be a long-term option. CVD doesn't get very good levels of performance and is expensive and complicated, and many people are looking for immersion protection, which it doesn't really provide, so many are moving away from it given the low performance levels and complexity and high cost. And then the NanoProof is easy to apply, has multiple application methods, as high performing as you would like, and is very economical. So now we'll cover some case studies. First up is a Bluetooth headset application that we helped a customer implement. They were looking for protection from sweat and splashing water. They didn't need full immersion proofing though. We treated parts for this customer in addition to some evaluations at the customer site. This was around a 6-month program, and we ended up selecting NanoProof 4, which was sprayed on all the parts excluding the audio components, and did end up yielding an IPX4 level of performance. Next up is a wearable device application looking for protection from sweat and splashing water. They did not need full immersion, mainly just focus on rain, sweat, and shower exposure. So IPX4 was required performance and IPX5 was a desired. So in order to get this specified in, we initially tested some parts via spray. The customer identified some high voltage components which needed additional protection via spot treatment. We ended up selecting a spray of 4.0 and then a spot treatment of 8.4, a more robust option on some of the more sensitive components. And this ended up passing the customer's IPX5 requirement or desire. Outdoor home electronics, as many of them are becoming Wi-Fi enabled, are an excellent application due to their exposure to the elements and need for reliability when exposed to humidity and water. So this particular customer had a device that was going to be mounted a few feet up on the wall of a home, and they needed protection from splashing water, rain, and irrigation equipment, but full immersion proofing was not needed. They were looking for IPX5 and IPX6 if possible. Aculon and this particular customer collaborated to determine that a robust option 5.1 was needed to protect their high voltage components. So excluding the audio speaker and optical components, all electronics are sprayed with NanoProof 5.1, and then the electrical connections are made using a diluent solvent. Hearing aids are another great application for us. We have a few customers that are in production here. They're looking for protection from sweat and splashing water. Full immersion proofing is not needed. They were hoping for IPX3 and IPX4 if possible. In most cases here, we actually just shipped out samples and the customer tested successfully. They utilized the NanoProof 4.0 for this material, and excluding the audio components, the electronics are sprayed using a PVA valve. And they passed the customer's IPX4 levels of performance. Another great application are cell phones, which are all moving towards some level of waterproofing. They're looking for protection from sweat, splashing water, high pressure water, and also full immersion proofing. So we're directly collaborating in conjunction with several cell phone manufacturers and Henkel, working towards IPX7 success. NanoProof 7, and then not listed here, also 8.4, are currently the top two choices for cell phone applications, since they're our most robust treatments and they're looking for full immersion proofing. And we do hope to have some of these programs commercialized within the next few months to year or so. So to summarize, NanoProof waterproofing offers high levels of performance up to IPX7 or greater, continuous production, extremely fast cycle times due to no masking and no cure, push-through connectivity, which is the ability to make a connection after the treatment has been applied, and the ability to rework. So unlike CVD or traditional cured conformal coatings, you can still rework the coated boards. So Aculon will work with you to determine the best application process. We have a variety of methods and a flexible approach. Starting with a simple customer trial, we can provide you with samples of the NanoProof materials that are best suited for your application. You can coat your parts and do some initial testing, and then we can carry on from there. Aculon can do the trial for you. If you are able to send us some of your parts, we will treat your parts for you and then return them for your initial testing. And then based on your feedback, we'll iterate from there. And then even better, if our technical teams can set up a meeting to set up a DOE, we can potentially treat several parts with several different options using several application methods. From there, we can compare the performance of each of these different options and move on from there. So in summary, Aculon is a leading supplier of nanoscale repellency technology. We've qualified NanoProof in production on numerous applications. It's extremely easy to apply and cost effective. The NanoProof series provides options based on your performance requirements and has proven to outperform competitive technologies. In addition, Aculon supplies the NanoProof series globally. So with that, thank you for attending. now we will get into whatever questions you might have. So I'm going to pull up my question box, which I presume people have been filling in during the course of the webinar. And as you have questions and as I'm answering questions, please continue to fill them in. So first question is, does Aculon have a coating that stops water vapor permeation through ABS or polyester plastics? That's a good question. We may have some coatings that can help inhibit water permeation. That's not necessarily the goal of preventing water vapor from absorbing into the plastic. So I'd have to talk to the technical team, but I will reach out to you after the webinar, and we can talk about that particular application. Next question is, will I get a copy of the presentation? So yes, we are going to email you a recording of this webinar, and we're also going to email you a copy of the slide deck. And in addition, all of our past webinars are also available on the Aculon NanoProof web page. The next question is, how do I apply the coating in case masking is required? So first of all, I would suggest that we would look at options for eliminating the masking and using some sort of selective deposition. From there, it would depend on what the masking material is, which NanoProof material we're looking at. There's not a quick and easy answer to that. We can find a solution, but it would depend on many factors in your application, so we'd have to talk further about that. Next question is, does NanoProof affect the LED component? In other words, its light output of the LED after coating with this material. Another great question. So if you want to coat over your LED or any sort of optical component, first of all, we would recommend that we utilize the coating free of UV dye, because the UV dye does have a color and it will impact the optical performance. Then from there, some of our thinner coatings are optically clear and will not have impact. Some of our thicker coatings, most do have 100% transmission, but there is some diffusion, so it depends on the application. For some applications, having 100% transmission but some diffusion is okay. And for others, it's not okay. So it's kind of case by case where we take that. But also what we found is that coating over the actual light emitting part is not necessary. It's the resistors and other components on the part that need the coating itself. So in those cases, we recommend using some sort of selective deposition, which is very easy to set up, coating the resistors and other parts, and just leaving the LED alone. Next question is, do waterproof coatings degrade with temperature exposure, and is there a temperature range? So that's a great question. The coatings are stable at low temperatures and up to 225 to 250 Celsius, depending on which material. So in almost all cases, these applications are underneath that range. We do have some customers who will even put their boards through low temperature reflow after coating with Aculon, and the Aculon coating survives the low temperature reflow. Next question is the coating being assessed for tin whisker mitigation potential. So no, at this time we're not evaluating for mitigation of tin whiskers. If you would like to assess whether that does help in your application, we'd be happy to coat your parts or send you some samples to have a look at that. But currently the main focus is for water protection on accidental water immersion. Let's see, what's the next question? What's the best method to confirm the coating thickness at thicknesses less than 5 microns? So the technique that we utilize here at Aculon to measure the film thickness is utilizing a form of an optical technique called thin film reflectometry. And that is using a Filmetrics device. And so it allows us to take very quick and simple thickness measurements in the micron and in the nanoscale range. Next question is, have you tested the coating for direct UV exposure? We haven't done significant direct UV testing, but in general, most of these coatings are intended for use within an enclosure, not in an area where they're going to be exposed directly to UV light or to abrasion. Next question is, the NanoProof 8.0 halogen free? I believe it's halogen free. I'll have to double check and confirm, but I think the answer to that is yes, it's halogen free. Next question is referring to required coating ranges for aerospace applications, and essentially saying that these are too thin for aerospace applications. And that's correct. These coatings have not necessarily been designed for aerospace applications. The main focus is for accidental water immersion, protection from splashing water on consumer devices, industrial devices, not necessarily aerospace or mil-spec applications. Next question, how do you avoid or protect connector pins during the coating operation? So as we discussed in the presentation, most of the NanoProof coatings offer what we call push-through connectivity. So you don't need to avoid or protect the connector pins. You can coat over them, and then you can make the connection afterwards if the coating you're using offers push-through connectivity. And if it doesn't offer push-through connectivity, then you would either use some sort of selective deposition to avoid coating that connector pin, or you would coat the connector pin. After it's cured, you would then put a diluent coating on it, and that diluent coating would soften the coating on the connector, and you could make the connection. Next question is, have any of the NanoProof materials been tested for biocompatibility? That's a good question. I do not believe that the NanoProof materials specifically have gone through any biocompatibility testing, but we have no reason to believe that there would be any problem with them passing. So if you want to reach out, we can discuss your specific application and see if it makes sense. So next question, can NanoProof replace acrylic conformal coatings I'm using currently? So yes, the NanoProof can absolutely replace your acrylic conformal coating. And you ask if there's any pros or cons, and that's kind of getting into the specifics of your application. So let's discuss that. I'll reach out. I have your contact information here, and we can discuss your application and see how we can replace that acrylic coating for you. Next question is, can Aculon coat over flux coatings? And does the material offer protection from chemicals other than water? So let's cover both of these separately. So first, can it coat over flux residues? So technically, yes, it can coat over flux residues, but we've done some testing to compare the performance of a clean board versus a board that is contaminated with a no clean flux, and the difference in performance is fairly drastic. So we do recommend that flux is removed from the board, that the board does not have contamination on it before coating the board in order to get the best performance. Then, does the material offer protection from chemicals other than water? So yes, and that depends on which coating you select. So we have either hydrocarbon-based coatings or fluorinated coatings, and the fluorinated coatings are going to provide protection from a wide variety of chemicals. The hydrocarbons will as well, but the hydrocarbons may be more susceptible to getting dissolved by certain solvents. So again, case-by-case basis, let's talk about what the exposure conditions are for your application, which chemicals you're concerned about, and we can talk about which NanoProof is going to be best suited to protect from those chemicals. The next question is, what does it mean process optimization intensive? So by that, it means that you certainly will often need to iterate to find out how to ideally treat your board. So every single application is unique. So what we found is that it's rare that we can provide a set of instructions, an ABC guide to tell you how to treat your part and get protection and not have problems. So every single application is going to require some iteration and some back and forth and optimization of the coating process so that you get the desired level of performance, so that you get a robust and durable coating, and that you don't have any undesired side effects, that the coating isn't going where you don't want it, et cetera, et cetera. And so that can be, require a few back and forths. Let's see. Next question. So next question is, how long are hydrophobic characteristics maintained? Our product life needs to be from 5 to 10 years. That's another good question. So the NanoProof products, inherently, there's nothing that will cause them to break down or fall apart over 5 to 10 years. There needs to be some sort of exposure condition that will damage them. So say intense UV or abrasion or chemical exposure, or a temperature range that's unacceptable. As long as those are kept in control, then there's no reason that the NanoProof won't last the lifetime of your device. Another question about how do we deal with materials left behind by no clean solder paste. So to reiterate on that one, we certainly recommend that no clean solder paste is removed before you coat. We have confirmed that if the no clean flux is left behind, it can have issues. Next question is, what volumes are you capable of? So we, especially in conjunction with our strategic partner Henkel, are capable of producing in pretty much any volume required. So if the volumes require it, we would most likely look to get Henkel involved and discuss how we can meet your production needs. If the volumes don't require it, then we can, of course, produce here at Aculon. So I see no reason why there would be any volume concerns with almost any application that we could be discussing. Next question is, how long does it take to cure after the NanoProof is applied on a PCB? So again, depending on which NanoProof, it could be a matter of seconds to 10 to 30 minutes. But almost all of the NanoProof materials are tack-free and able to be handled within a minute or so. Next question is, what are the steps required for rework? So to rework the part, you would take a specified diluent solvent. There's a specified diluent solvent for each of the different NanoProofs, and you would either flow or drip that onto the board, and that will essentially dissolve or melt the NanoProof coating. You would then physically remove it and do your rework, and then you could reapply the NanoProof to that area. Let's see, next question. How easy is it to scratch the coating off from PCBAs? So the NanoProof coatings are not cross-linked, so they're not as abrasion resistant as, say, a traditional cured acrylic or epoxy. It's perfectly acceptable to handle them, and they can handle, routine handling, but they're not designed for significant abrasion resistance, so you would not want to purposely try and scratch them off. But as long as they're inside some sort of enclosure, not being handled aggressively, they're perfectly fine. Next question is, what is the viscosity of the NanoProof coatings? There's a wide range of viscosities. The lower level protection coatings are very low in viscosity, usually anywhere from 1 to 10 centipoise and able to be sprayed. The higher level protection coatings are in the range of a few hundred to a few thousand centipoise, and we can also optimize the viscosity based on your application needs. Next question, is there an optimal range of the acidity of the liquid with the NanoProof coating? If you can rephrase that question, whoever asked about the acidity of the NanoProof coating, I'm not quite sure what that is referring to. The NanoProof coatings are robust to most acidic coatings, and then the coatings themselves are solvent-based, so they're not, a pH isn't relevant. Next question is, do you need to remove the coating to rework components? That depends. Some of the coatings are thin enough that you might be able to get away with reworking without removing. Some of the thicker coatings you would certainly want to remove, but you could, depends on your application, you could certainly try to rework without even removing the coating, and you may be successful. Next question is, how do I buy this material? So that's a great question. My email is on the webinar page. Send me an email. We'll talk about your needs. We'll talk about your location, and I can send you a quote, or I can refer you to the appropriate distributor that can support you in your country. Next question is, does the material stay where it's spray coated, or does it wick up connectors like a silicone or acrylic coating does? Great question. So no, it does not wick. It stays in place. The thicker coatings are designed to go down and essentially kind of gel up and form where they belong. And then the sprayed coatings actually partially dry on spray, and so they don't wick and spread to where they're not sprayed or coated. See, next question is, does it meet the 94V0 flammability rating? So yes, we have not been through that testing, but yes, all of them would pass that flammability test after application. They're non-flammable. Next question, is there a lifetime for the coating? 1 year, 3 year, 5 year? Again, the lifetime of the coating depends on the exposure conditions. If there's no damaging exposure conditions, then it'll last the life of the device. If it's going to be exposed to chemicals or significant temperature, then that may have an impact, but it's a case-by-case basis, and we can talk about the exposure conditions. Next question, is NanoProof available in a spray bottle for the reworking? So no, the NanoProof is not compatible with a plastic spray bottle. It comes either in syringes or it comes in a bottle, and it needs to be applied with a non-atomized sprayer. And these are relatively cheap and easily sourced. Next question is, can the coating transfer by contact from one surface to another? The answer to that is, for one of the coatings, yes, and for the rest of the coatings, no. So the 4.0 does have some gel-like behavior, and so it can potentially transfer from one surface to another. The rest of the coatings are cured and set in place. Next question, are there any cosmetic consequences of the PCB? Some of my customers like a shiny and pretty solder joint. Does the material change any visible properties of final assemblies? The thinner coatings may have some impact on the look, but they will essentially leave the PCB looking as is, whereas the thicker coatings will certainly, look like the coating has been coated. It will not look like a shiny cured acrylic, but it still has a attractive and good look to it. Next question, is the material impervious to gas fumes or just water? I'm not sure if you mean if the gas fumes will destroy the coating or if they'll just migrate through, but no, gas phase molecules over time will still migrate through the coating and through the board, no differently than water vapor still would. But they won't destroy the coating, if that's what you're asking. Next question, is the material clear, transparent, or does it have color? So all of these coatings have a UV dye, which inhibits either some blue or green color to the coating. But we can also remove the UV dye, and then they will either be clear or have kind of a white, hazy look to them. And so with that, it looks like the questions are winding down. That was an excellent list of questions. Certainly kept me on my toes, so thank you for that. My email is there if you have any questions. If you'd like to talk about your application, sort some samples, please send me an email, and you'll be hearing from me as well. So with that, we'll end the webinar. Thank you very much.
Thank you. We appreciate you taking the time to listen to that, and we hope we can help solve any waterproofing needs that you have. We've got a broad variety of solutions, as Mario outlined, and fairly flexible in application processes. So I think it'll be a great opportunity for us to work with you guys to see if we can meet your needs. So we appreciate you taking the time, and with that, we'll sign off. Thank you, and have a good rest of the day.